So we are going to start chapter 1, Polynomials, class 10, part 3rd. So we'll start with dividing of two equation, x plus 2 and 2x square plus 3x plus 1. X plus 2 is our divisor, 2x square plus 3x plus 1 is our dividend. So we will solve this using long division method that we have done in our class 9, right? So we can do it easily, but still I'm remembering you again. So first we will multiply with 2x, so I will get plus 2x square. Then I will multiply 2 with 2x, so I will get 4x of plus. Now I will change the sign, minus minus, then 2x square will cut with 2x square, then 3x minus 4x will be minus x, then plus 1 I will get plus, minus 1 plus 1, then I will multiply it with minus 1, and then the same we will do and change the sign, and I will get remainder as 3. We know this. Now here's our question. Find all the zeros of 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2 if two zeros are root 2 and minus root 2. So we are given the two zeros of this equation. Now we have to find other zeros. So let's see how to do these type of questions. So I'm given two of the zeros already. So I can write root 2 and minus root 2 as x minus root 2 x plus root 2, right? Because that's how we find the zero, right? So I have written them as like this. So now you can see that there is a identity a minus b a plus b, which state a minus b a plus b is equal to a square minus b square. So we will do the same here. It will be x square minus root 2 square, and I will get x square minus 2. Understood this much? After I get x square minus 2, I will take it as divisor, and the equation I was given 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2, I will take it as dividend, and then I will use long division method. We all know how to use long division method, so here we will do the same, and I will get remainder as 0. Now I have got the quotient 2x square minus 3x plus 1. Now I will middle split it to get other zeros other than root 2 and minus root 2. So I am middle splitting this 2x square minus 3x plus 1 like 2x square minus 2x minus x plus 1, then 2x is common, x minus 1 in bracket, minus 1 is common, x minus 1 in bracket, then 2x minus 1 I will get, and x minus 1 in the other bracket. So the value of x will be 1 by 2 here, and x value will be 1 there. So I have got other two zeros. So total number of zero of the equation 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2 are 1 by 2, 1, root 2, and minus root 2. Understood? So before doing the next question, I would like to memorize that dividend is equal to divisor into quotient into plus remainder. So I can also write in the form px is equal to gx into qx plus rx. Okay, it was so easy, as we have done this in chapter 1, real numbers. The question is like that: we have to give an example of any polynomial in such a way that the degree of the quotient should be equal to the degree of remainder. So here you have to think a little bit. So what you have to do, if you want the degree of quotient and remainder same, so you have to take the dividend and divisor of the same degree, so that your quotient will be let's say degree 1, then remainder will also come in degree 1. Okay, so let's see how to. So in this question you have to take as let. So let px or dividend be 4x square plus 2x minus 2. I have taken here quadratic equation, and gx or divisor as 2x square plus x minus 1. So here I have taken dividend and divisor of the same degree, so that I will get the quotient as the degree 1, as well as the remainder I will get, it will be of the degree 1, right? So this is how you have to make your brain work. So the divisor I have taken and dividend I have taken, I have done long division method, and the remainder I got is 0 and quotient as 2. So you can see the degree is same of both of them. So you have to use your brain here, that I have taken divisor and dividend degree same, so that I will get the degree of quotient and remainder same, right? So this is how you have to do this question, and we are completed with your exercise 2.3 also, and this chapter, that is chapter 2, polynomials. So thank you.